Alright guys, welcome to chapter 13. Today we're going to be talking about mobile device forensics. Our core objective here is to understand cell technology, correct device seizure protocols, and look at things like SIM cards. We're going to review our acquisition tools again, especially for the different types of mobile devices. Now, for the exam itself, remember that mobile forensics is heavily tested regarding the handling of the evidence. The primary directive at the crime scene involving a mobile device is network isolation to prevent data destruction. We're going to be talking about things like Faraday cages and other devices here. All right, so our learning objectives today are broken down into three key areas. First, we're going to cover the fundamentals. We need to understand things like SIM and EEPROM and ROM, as well as network architectures like GSM, CDMA, and 5G. Next, we're going to be covering seizure. We're going to be focusing on handling proper ways of handling cell phone devices to prevent things like signal loss, data alteration, or remote wiping. And then finally, we'll be reviewing extraction methods for acquiring evidence from SIM cards, internal memory, and external SD cards. Now, for the exam, you need to know the difference between extracting data from internal storage versus a removable SD card. Removable media often can be analyzed using standard computer forensics tools, whereas the internal memory may require specialized mobile suites of tools, okay? So let's look at the key components inside of the mobile device. For instance, the microprocessor, that's going to be the brain of the device. We've got ROM, read-only memory. This is going to store the operating system. We're talking about Apple or Android here. We've got RAM, random access memory, which is the volatile memory for running apps. And then we've got flash, or otherwise known as EEPROM. It's the non-volatile storage that holds things like photos, contacts, settings, and this is what we're going to be looking at specifically. Now, you do need to memorize the acronym EEPROM, electronically erasable programmable read-only memory. You must know that this is a separate chip where the data will persist even if the phone is powered off, just basically knowing that EEPROM memory is a non-volatile storage medium. So the first part of the phone that we need to understand is the SIM card, or otherwise known as a subscriber identity module. Now, it's a smart card that identifies a subscriber to the cell network itself. It's going to hold a whole bunch of information, including the ECC ID, which is a serial number of the physical SIM itself. These are normally IDEC, and the IMSI, which is the International Mobile Subscriber Identity, which is the user ID. Okay. Now, we need to understand that the SIM can store its data like contacts or older SMS messages or even like a recent call history. But just know that sometimes it's going to be protected, especially if they have a PIN enabled on their phone. So it will have a PIN unblocking key. All right. So this is definitely going to be another one of those guaranteed topics on the exam. You must be able to distinguish the difference between an ICCID and an IMSI, and know that entering a PIN incorrectly too many times will lock the SIM, requiring the PIN unblocking key from the carrier to unlock it. So Verizon, T-Mobile, whomever the SIM is from. Now, historically, there's been a whole bunch of differences in cellular networks. We've got like 4G, LTE, 5G. Now, they all use SIM cards now. So GSM, Global System for Mobile, is used globally. This is used everywhere. T-Mobile has been one of the big ones on this one, and it uses a SIM card for user identity. Now, this is going to make it easier to like swap out phones because you could just take the SIM card and move it to a new phone, and normally the carrier is all great and grand. The other way is a CDMA, which is the old way that Verizon used to do things, which is code division multiple access, and it's primarily used in the U.S. And it was handset based. So they didn't use SIM cards. Instead, they used the user identity, the IMEI, to tie the phone strictly to the tower itself. So it'll use like the device's serial number, like the ESN or the MEID. Cool. Now, CDMA is largely obsolete. Legacy devices still will appear, and so we do need to understand that they do still exist. And so that's why we still need to understand that the MEID and the ESN are associated with the CDMA. Now, IMEI is associated with the GSM, with the SIM cards. Now, properly handling of evidence starts with isolation. Our primary goal is to prevent the device from receiving a remote wipe command from the suspect or overriding the data with new incoming calls or texts. So the first thing that we may use is called a Faraday bag. Now this is a standard tool, and it's a mesh line bag that's going to block all radio frequencies. It doesn't matter if it's cell phone, Wi-Fi, or Bluetooth. Now if the bag isn't available, we can use the old school method, and we like to just say it's the paint can method. An empty, clean metal paint can is also a Faraday cage. If you think about it, it works like a Faraday cage because the signals cannot penetrate the metal can. Alternatively, if the device is unlocked, you can immediately enable airplane mode and manually disable Wi-Fi, and Bluetooth is another methodology that you can use. Now, for the exam, we need to know that Faraday isolation exists. The exam may present a scenario where you have a seized phone and it's ringing inside of an evidence bag. This means your Faraday isolation failed, and the device is at immediate risk from being remotely wiped via a cellular network. So we have to be careful about that and understand that what methods can we do to isolate the phone. Equally important to isolation is power management. Our job is to keep the device alive. If a phone powers down, you lose all of the RAM data, including running apps, and a lot of times the vital decryption keys that you need. So upon reboot, the phone's also going to enter a BFU state, which is before first unlock. And this is a heavily encrypted state where the user's passcode is required to be entered before it will let you start using the phone again. Therefore, you must connect the device to a portable battery and block Wi-Fi signals and other signals immediately upon seizure. So you do need to know the distinction of BFU, before first unlock, and AFU, after first unlock. And that's very critical because in an AFU state, the decryption keys are held in memory, making logical extractions a lot easier. But remember, if you let the battery die, we're back to a BFU state, which means we need that PIN code to be able to unlock the phone. Now, there are three different types of acquisition methodologies here. The first one's going to be the manual acquisition. Now, it's going to involve scrolling through the phone and taking photos of the screen itself. It is easy, but not forensically sound, and it entirely misses deleted data. The next method will be the logical acquisition, which uses the device's API. You'll use things like iTunes or ADB and request active data. It's fast, but again, we're going to miss deleted data or anything unallocated. Now, the gold standard here is going to be physical acquisition. It's that bit-by-bit forensic flash copy, and we want this because now we can also try to recover deleted information from the phone. But it is quite difficult to perform on newer phones because they're pretty much all encrypted. We do need to understand for the exam the limitations of each. Like, only physical extraction will give you a hex dump that will allow us to carve unallocated space. In other words, recover deleted files or photos. Now, talking about Apple, per se, we have to refer to it as the walled garden. These devices are highly secure and encrypted. For logical extraction, an iTunes backup will yield photos, SMS, notes, and call logs. If we're dealing with that physical extraction, it's often going to be very difficult to get, and it needs exploits like the checkmate or jailbreaking for the device to actually work. Now, the primary artifacts that we're going to analyze here is going to be the iOS SQLite databases. So we're going to be looking for the sms.db or the .plist files. Remember that the plist file is a Mac or an iOS file, and it's equivalent to the registry. So it's going to store user preferences and application configuration settings. Now, if we switch turns and we go back to the Google devices, this is known as an open platform, which is it means that it's running on a Linux kernel. Now, the primary tool for logical acquisition is ADB, or Android Debug Bridge. Okay. Now, this is going to require USB debugging to be turned on in developer settings, but if it is, it will let us get the full acquisition of the phone as long as debugging is turned on. Now, the physical access often requires rooting of the device to get full access. It's easier on older models, harder on newer models, just like anything in the IT world. Now, regarding the file system itself, under data directory, this is the main target because this is where we're going to find all of the app databases. Now, for the exam, you need to understand the term rooting and jailbreaking are synonyms. So we're trying to get admin access either on an Android or an iOS device. Now, once we have administrative or super user access to the device, now we can do full physical images and pretty much anything we want to the phone. Now, let's look at the commercial tools real quick. Because mobile operating systems update constantly, forensics is going to change as we go along as well. And so there are a few different tools that you can use. The first one is going to be Celebrite, which is the industry standard. Okay. It's a hardware unit that extracts data from thousands of models, and it's famous for its passcode unlocking capabilities. So even if you don't have the passcode, it can a lot of times get around it. The other way is using Oxygen Forensic Detective. It's a powerful software suite. It's good for cloud extraction, parsing third-party apps like WhatsApp or Telegram. And then lastly, we have the Magnet Axiom, which is excellent because it integrates mobile evidence seamlessly with the computer evidence. Magnet Axiom allows you to build like visual chat lines and stuff like that from different tools like Signal or any of the chat applications out there. You do need to familiarize yourself with Celebrite and Oxygen Forensics because if the exam comes to you and says, hey, we have a tool that is used to logically or physically extract data from a locked smartphone, which tool would you use? And Celebrite would always be the correct answer in these cases. So once we've extracted the data, what are we actually looking for? The first thing that we're going to look for is going to be for the SMS and MMS messages. These are the text messages often containing timestamps or sender information. We'll look at call logs for dial, received, or missed calls to establish relationships. We'll look in their contacts to provide address books, emails, and physical addresses. We'll look at their web history to see any cached images, cookies, whatever, which could also reveal intent. And then we could look at photos or video, which is often going to contain EXIF data, the metadata that we're looking for. This could be GPS coordinates to show you exactly where an image was taken. Just like in Chapter 10, EXIF data is a recurring theme. Always extract the metadata from photos to establish geolocation timelines. Big tip here for the exam itself. Because that geolocation evidence is going to be a track and beacon. It's going to provide that geolocation evidence for a court case. We can track movement through three main methods. The first one's going to be the GPS data itself. It's going to provide highly precise locations pulled directly from navigation apps like Map or Waze or whatever app they have on their phone. The other thing they can do is use cell phone triangulation. Now, this will help provide an approximate location because cell phone towers, it will just show us which cell phone towers we were connected to, and we can obtain call detail records or CDRs from the provider themselves, from those towers themselves. And then lastly, we could use Wi-Fi positioning to determine location by looking at what Wi-Fi networks were visible and when was the last time the phone saw that Wi-Fi network. That does get tracked in the phone, and it does help quite a bit for an investigation. Now, CDRs must be subpoenaed from the mobile carrier. So if you want those call detail records from AT&T or Verizon, you're going to have to subpoena them from the call provider themselves. They are not stored on the device. A CDR is going to have like a timestamp, a caller, receiver, and even the cell tower that the call was routed through, so we can see the route that the call went through, which is helpful for if we're trying to do mobile triangulation of where the phones were as well. Now, the biggest hurdle we're going to get is going to be in the encryption barrier. We do need a couple things. Like, for one, we may need to know the passcodes, because without a modern pen, phones like everything from like iPhone 5S and up are essentially, they're going to be encrypted bricks. Okay. We may need biometrics like Face ID or fingerprints, but there is a legal precedent in the US that generally takes at the Fifth Amendment law enforcement. So if a suspect unlocks the phone with biometrics, but not with biometrics, they don't have to give us the passcode. A lot of law enforcement will try to ask you to be like, hey, will you unlock this phone for you? And you're allowed to do that. You can also refuse by saying, I plead the fifth. In other words, I don't want to self-incriminate. The other thing is brute forcing. If we don't have a tool, we can use things like Gray Key to attempt to guess the passcode, but it has built-in delays and timeouts that make this a very slow process. Now, for the exam itself, you do need to know some of those legal intersections of forensics. Understand that compelling a suspect to provide a passcode often invokes the Fifth Amendment protections, which makes brute forcing tools or discovering written passwords very critical for us. They can also revoke the permission to get into their phone at any time. So we have to be very careful about when we gather that evidence versus when the evidence was revoked from the court cases themselves. All right, to summarize Chapter 13, we need to understand handling and by using Faraday bags and keeping it charged, because remember, BFU or AFU stages are kind of a pain in the butt. If it dies, we're back to BFU, which is highly encrypted. We need to know the architecture, like the GSM, CDMA, and the file systems of iOS and Android. We need to understand those. We need to understand acquisition, whether or not it's a logical extraction or physical extraction to help recover deleted data. And then we need to know some of the tools like Celebrite or Oxygen to help with collecting this information. Now, the most frequent mistake made by amateur investigators is turning a seized device off. Remember that we need to isolate, power bank, and transport. Don't turn it off. All right. So that's going to conclude Chapter 13. If there's any questions, let me know. Otherwise, I will see you in Chapter 14 for malware forensics. Just remember, you're going to need to know those differences between logical, physical, and manual extractions and the use of Faraday bags and power requirements. All right. See you for malware for forensics.